welcome to lesson number 3. In this lesson we will talk again about operators, and I will make a really small introduction to the if statement, which is a loop. So let's open up our Eclipse program and close the welcome page, and then you should see our last lesson here. Now we will create a new project, a new Java project, right click, new, project name, lesson 3, or whatever name you want. Click finish, then you should go there, source, right click, new, package, finish, right click over the package, class. We will create our main, methods and class, finish. So we'll make some space so that we can work. The simple operators that we learned the last time are the following: addition, abstraction, multiplication, division, the remainder operator, and the assignment. So let's put all of them inside a command line. Remember what we told the last time, that if we want one line of a command, then we just click twice the slash button. But if we want comment for multi-lines, then we press slash star star slash, and then you just press enter, and you can write here whatever you want. It's all comments, and the compiler will ignore it. So we have here addition, abstraction, multiplication, division, the remainder operator, and assignment. So let's learn some more of them. Keep also in mind that in Java there is a priority for every operator. That means that if we have in a line many calculations, we should know the priority level of each one of the operators as much as the associativity. That means from left to the right we do the calculation, or from right to the left, the direction more commonly, so that we can determine the result of many calculations in a line. I will teach you in this lesson the most common operators for our current level, and as we go on I will also show you examples the rest of the operators. For a full list, check the description below and click the link. So, operators volume 2. We start with the increment operator, which is the plus plus, then the decrement operator, which is the minus minus. What the increment operator does is imagine that you have a number 5, for example. If you put the increment operator, the 5 will become 6. One more time the increment operator, the 6 will become 7, and so on. And the decrement operator does the opposite, from 7 to 6, from 6 to 5, and so on. So the next one is this. It is used in place of the following. So x equals x plus something. I will show you examples later. So then we have this one. It is used in the place of x equals x minus something. Then is this one, again x equals x multiplied by something, and this one you can imagine what this does, and this one also. So then we have operators used with Boolean. This means true or false. So we have the creator, this is the creator one, this is the creator or equal than, you should have learned that in mathematics this is the less than, this is the less or equal than, then we have the equal to, then we have equal to, and also equal in type. Then we have the not equal to, then we have the negative, the opposite. So if we say, for example, something is true, then something is true. If we say something is so, and we write it so, then we can read it something is not true. And this is equal to something is false. So we could say that false equals not true. You can read it as not. So the next one would be the conditional and, which means that the calculations on the left of this symbol should be true, and the calculations of the to the right of the symbol should be true, so that the whole statement gives you true. If the calculations of the left side or the calculations of the right side are false, then your statement is false. But we will see everything in detail later on. So then we have the conditional or, and the conditional or means that the calculations on the left and the calculations on the right should be true, both of them true, or at least one of them should be true, so that the statement gives you back true. The statement will give you false only if both of them, both left and the right side, are false. So this is everything you need to know right now, and that is all that we will use for the coming lessons. But if we use something more, I will be happy to explain you at that point. So let's do some practice so that you can understand what do we mean. Let's create a variable. I will write it down, create a variable. So an integer, like we learned in the last lesson, an integer x, and it should take a value of 10, for example. Then we should do x plus equal 2. I will make it so that you can see it, and semicolon, and then we should write the system out print line x, and we will understand what that does. So our variable had a value of 10, and then we wrote x plus equals 2. What that does is, like we wrote above, x will take the following value, x plus 2. So it should give us 10 plus 2, 12. Let's save and test it. 12. So we were right. Let's move on. We'll make it with 4. So let's test it one more time. 8. Why did we take 8? Because x was 12 at that point that the compiler read that line. And then we tell him, take the x and you can abstract 4 points. Then we have 12 minus 4, 8. And here we have our result. So exactly with the same way we will do further. Let's say 5, for example. Let's see how it goes. 40. Why? Because 8 times 5 equals 40. Then we can do this one. And how could we take the 8 back? Just think about it. Did you find it? I hope so. So we can test this one too. 8. Do you see what I did here? Try to understand it. I did the following. I said I will give the following value to x. X divided by 5. So what does that mean is 40 divided by 5 equals 8, and that's why I took 8 here. And then we will make x, so let's say with 3. What did I forget here? So let's run it, and I took 2, because the remainder, if we do this calculation, 40 divided by 3, the remainder is 2. What remains is 2. Now we should see also the increment. What value does our x has? 2. If we do this one, then we increment the value by 1. It should give us 3. Yes, it did give us 3. And let's decrement now the value by 1. So it should give us 3 minus 1, 2. It gave us 2. So now, for the purpose of explaining to you the Boolean operators, I will use the if statement. This is a loop. I will make an introduction to loops in a coming lesson. So let's start by making 3 variables. So all 3 will be integers. Let's say alpha. This is the name of my integer, and we will give a value of 10. Then we will make another integer. We will name it omega. We will give a value of 20. Then we will make another integer, and we will give it the value of the name of delta, for example, and the value of 10. So what is an if statement? An if statement is exactly what I will read to you right now. Exactly what I write, this is what it does. So we say if what I write here in the parentheses is true, then we open the curly brackets. So if what I write here is true, then whatever command I write here inside the curly brackets will appear. If what I write here, the statement that I will write here, is false, then whatever commands I have here inside the curly brackets, it won't appear. So I will write if what is in the parenthesis is not true, do nothing. That's what we say here. And here if what is in the parentheses is true, then do the following. So we will write, for example, 8 is true. So what did I write here? I wrote true. True is always true, right? Let's see. Yeah, it is true. So the compiler agrees with us. Let's try something else. Let's try something with our from the mathematic. So I will say 2 equals 3. Is it true? I think not, but let's see what the compiler says. He says nothing. So it is not true. But if we say 2 equals 2, it is true. The compiler understands it. So let's see, what do we have here? We have here some operators to see. So let's see the greater. Is true greater than 3? No. But is 4 greater than 3? It is true. Do you see what I do here? And then we can also use our variable. So is alpha greater than omega? And what I do say here is really, if alpha, if 10 is greater than omega, omega is 20, so I practically say if 10 is greater than 20, then do the following, then system out print line, it is true. So let's see what happens. Nothing. If what is in the parentheses is not true, do nothing. But if we say if omega greater than delta, so if 20, because we gave the value of 20 to omega, is greater than delta, we gave delta the value of 10, then print this one. So compiler, it is true. So 20 is greater than 10. If we say greater equal to 10, it is true. If we say if alpha greater or equal with delta, then print this one. What do you think that we will take back? It is true. Why? 10 is not greater than 10, but 10 is equal to 10. And exactly the same way you can do it with less. So less or equal is that it is true, or is 10 less than 10? No, it is not true. So this is with greater than, less than, greater or equal than, etc. So we also saw the equal to. Let's see the not equal to. Let's see it with normal numbers. So we can say 10 is equal to 10. This is true. Yep, compiler agrees with us. We could also say 10 is not equal with 10. Is it true? No, it is not true, because 10 is 10. But we can say 10 is not equal with 9. Let's see what the compiler says. It is true. And exactly the same way we can use our variables. Alpha not equal with omega. Is it true? Of course it is true. 10 is not equal with 20. But if we write 10 is not equal with delta, then we say 10 is not equal with 10. Is it true? No, it is not true. So this is the use of the equal to and not equal to. So we can also see the not. If we say true, if true, then do it. It is true because we write true. But if we write not true, Let's see what happens. Nothing. Do you know why? Because if what is in the parentheses is not true, do nothing. Exactly the same way if we write false, we'll take nothing because it is not true, it's false. We say it. So let's see it one more time with true. It is true. So let's see now the conditional AND and conditional OR. So we can say we open up another parenthesis inside the parenthesis and we write, for example, 10 equals to 10. Conditional AND. We open another parenthesis, 5 equals to 5. What do we say here? We say that 10 equals to 10. This side is true. And we say on the right side 5 equals to 5. This side is also true. Then let's see if we will take it is true. Or we should say it and we should change that and write, for example, conditional AND agrees. Both sides are true. Save. When I save, I always press the Ctrl S so that you know it. And then we run it. Conditional AND agrees, both sides are true. But if the right side is false, now it's false. 5 is not equal to 6. Let's press it. Nothing happens because conditional AND doesn't agree. If both of the sides are false, the conditional AND doesn't agree. You saw it. Now let's make both of the sides one more time true and press the run button. Conditional AND agrees. Both sides are true. So let's see what happens with conditional OR. And we will change that to conditional OR agrees. What did we say for the conditional OR? At least one side is true. So let's see it happen. Both sides are true now. Let's press run. Conditional OR agrees. At least one side is true. Let's change this side. We will say this side is true, 10 equals to 10, and this side is false. 6 equals to 5, this is false, right? One side is true, one side is false. Let's see what the statement is. Conditional OR agrees. At least one side is true. Let's make the opposite. Left side is false, right side is true. He agrees again. But let's make both of them false. What does happen if both of them are false? Also, conditional OR doesn't agree with you because it gives us back the false value. So that's it for this video. I want, as I said, to keep them as short as possible so that you won't get tired and learn what we do in these videos. If you like this video, give it a thumbs up, subscribe to my channel, check the description below, and stay tuned for more tutorial videos like this one. Thank you all for watching.